Hi everyone, my name is Madhav and I'm a professional tutor. Today I'm going to talk a little bit about SAT math. Doing professional tutoring for about 8 years, I've seen that most students struggle with SAT math only because not that they don't know the topic, but at times they're confused about strategies. They're not sure how to solve the problems fast, and SAT is all about timing. You have to make sure you're doing your questions correctly in good amount of time. So I'm starting this series of videos to share the strategies that I've shared with my students over time. And I've helped a lot of the students get really good grades with SAT. So I'd love to share that knowledge over with everyone who may benefit from it. The way I like to structure most of my lectures, I go through all the topics that SAT has. So these videos will cover 15 to 20 minutes of each particular topic. And then at the end of all the videos, I'll also keep constantly looking through the comments, see if anyone has any questions, and I'll try to create new videos based on the comments I get. If there are particular topics you want to understand and you want me to post videos for it, please feel free to do so. Also, since this is my first video, I'd request everyone to please hit the like button so that I can continue creating this content for everyone. So let's start off today with the heart of algebra. The topic for today is going to be linear equations. So before we jump into it here, I'm gonna just cover a few things here with linear equations. Right. So what really are linear equations? We've all learned about the line. It's something like this that we can draw. This is what you call line AB. And this is the denotation for it. Now with SAT, most of the linear equation questions would be focused around what a line is, if it's a parallel line, a perpendicular line. So let's learn a little bit more about this. The equation of a line. And this is something I would ask everyone who is taking these lessons to start creating an equation sheet for. So every time I say that this is something you should put down in an equation sheet, we're trying to create something that would be probably a 2 to 3 pager, and it will help you during your SAT prep on the last day. All you have to do is look at that equation sheet and that'll cover everything that you need for the SAT. So what's the equation of a line? It's y equals mx plus b. A lot of variables. For people who don't know, variables are essentially numbers, but we don't know the value of them. They could be any values. So y equals mx plus b is the equation. Here m is the slope and b is the y-intercept. All right, so how does that help anyone? Let's see. So this is a graph, and I'm saying this is my line. And let's say this point right here is 1, 1, and it also touches our origin at 0, 0. So what's the equation of this line? So the equation here, the y-intercept is the point where it touches the y-axis. In this case, it's touching it at 0. So when we write our equation, we'll write y equals mx plus 0. I haven't written down the slope or anything here yet, and the main reason being I'm going to go through it step by step. So the y-intercept at this point is 0. So this equation essentially becomes y equals mx. Now, how do I calculate the slope? And what really is the slope? So the slope essentially is how much or how less the line is really tilting, right? So since the line is pointing upwards, we know the slope is positive. If the line is pointing downwards, the slope is negative. So here we know the slope is positive, but how do we really calculate it? So m is equal to y2 minus y1 over x2 minus x1. Again, another important formula. I would definitely suggest we write this in the equation sheet. This is the formula for slope. Here y2 is the y-coordinate of the second point, y1 is the y-coordinate of the first point, and same thing with the x's. So the slope here is 1, which is the y-coordinate here, minus 0, which is the first y-coordinate, over x2, which is also 1, and x1, which is also 0. So it's 1 over 1, or the value is 1. So this tells me the equation of my line is y equals 1x or y equals 2x. Similarly, we could have multiple examples. Let's say we have a line, and this is the kind of questions you would be asked in SAT exam. If I have a line that's passing through, let's say 2, 3 and negative 1, 5, what's the equation of this line? So what I would do is I would say y is equal to mx plus b. The slope is equal to 5 minus 3. Order is important. If you take this one as y2, then this one is your x2, and you cannot interchange them in the formula. So it's 5 minus 3 over negative 1 minus 2, which is 2 over negative 3. And so my equation becomes y equals negative 2/3 x. I don't know my y-intercept yet, but I can find it out because I can plug in any of the points here into the equation. So I have 2, 3 and negative 1, 5. I can choose any one of those points to plug it into my equation. So I'm going to plug in the 2, 3 point. So y is 3, x is 2, and I can find my b value. So in this case, 3 is equal to negative 4/3 plus b. I'll add 4/3 on both sides to get rid of the 4/3. And I'll get 13 over 3 equals b. And so finally, the equation of my line is y equals negative 2/3 x. Sorry, negative 2/3 x plus 13 over 3. And that's how we find equations of a line. Now there could be a variety of questions here. I gave you 2 points out of which you had to find the equation of a line. There could be instances where the question might just give you a graph, and you have to take a look at the graph, find out 2 coordinates which you can use to find the equation of the line. With that said, one more thing I'd like to note here is a lot of times SAT will denote it something like this: f of x equals negative 2/3 x plus 13. We'll cover f of x in some future lessons, but just to give a fair idea, fx and y, they're kind of interchangeable. You can write f of x in place of y. All right, so with that said, let's talk a little bit about parallel lines. So parallel lines, what's the good thing about this, right? We have 2 lines. Parallel lines never intersect each other, and the main point here is that they have the same slopes. m1 is equal to m2. So if this line is y equals m1x plus b, and this is y equals m2x plus b, then m1 is equal to m2. So if I ask you a question, let's say y is equal to 2x plus 3 and y equals to 2x minus 3, are they parallel lines? Then yes, because m1, which is 2, is equal to m2, which is also 2. Similarly, we have perpendicular lines. Here, y is equal to m1x plus b and y is equal to m2x plus b. The important property here is m1 is equal to negative 1 over m2. So it's a negative reciprocal. That's how we spell it. So again, a sample question would be y equals 2x plus 3 and y equals to negative half x plus 3. These are perpendicular lines. So that covers the basics of what linear equations really are. They're all related to a line, and they'll always be in the format y equals mx plus b. If they're not in that format, I would recommend that any question you see with a linear equation, bring it into the y equals mx plus b format. It makes it very simple for you to solve the problems. All right, with that said, I'll go back to the SAT study guide. I like to use this because, again, this is the official study guide, and they have the topics that you need to cover. So with that said, let's take a look at the linear equations example that they have here. So I'll just zoom into it a little bit. The question says in 2014, County X had 783 miles of paved roads. Starting in 2015, the country has been building 8 miles every year. At this rate, how many miles of paved road will County X have in 2030? So, from what we have learned so far, right? 783 miles is already existing. So it's acting like something that's already present, which is very similar to the b intercept. So what we're saying is, in our equation y equals mx plus b, we're already starting off with 783, which is our b. So I'll say y equals mx plus 783. Next, they're saying that starting in 2015, the county has been building 8 miles every year. So starting from 2015, we go until 2030. That's 16 years because you started in 2015, so you have to count that year, and then you have 15 more years until you reach 2030. So we're trying to get to 16 years after 2014. So in this case, we already know that our time is 16 years. So our question is asking us how many miles of paved road would be present. Here, y is our miles. So this is what we're trying to find. And it also tells us that every year we are extending it by 8 miles, right? So in this case, we, let's see, how many miles of paved road will County X have in 2030? So every year we are building 8, which means our slope is going to be 8 miles per year. So 8 times the number of years, which we already said was 16, plus 783 will give me the total miles I need by 2030. In 2030. So again, what did I do there? I said the rate at which the miles are being built, which is the slope. The slope always can be related back to a rate at which something is either increasing or decreasing. So the rate is 8 miles every year. We have about 16 years. So I multiplied the 16 with the 8 to find miles. If you think about it in terms of units, this is miles per year times the number of years, giving you back the miles. You're adding miles consistently throughout the equation. And once you do this multiplication, that should give you your final answer as to what the total number of miles would be for this paved road. So let's do the multiplication quickly. Here, 8 times 16 is equal to 128, and then I'll do plus 783, which gives me 911 as my final answer. And again, this is in miles. So I hope that question made sense, and we'll move on to the next question. So I'll just scroll down just so we can confirm our answer, which is 911, and then we'll move to the next question. So in this question, 783 miles of paved road. Now we're starting in 2015 again, building 8 miles, and we are saying now we have n number of years. So this goes back to our equation. We had said 783 is our y-intercept. So we want 783 to be alone. That's something we'd figured out in the last question. So automatically you see options A, B, and D are all eliminated because we want 783 to be alone. So yes, that's one trick in the SAT. To do your questions faster, use the method of elimination. Here, as I know my B-intercept has to be 783, it cannot be A, it cannot be B, it cannot be D, because the y-intercept in A is 8, y-intercept in B is 2014, in D as well it's 2014. So it automatically tells me the answer is C, which is 783, and then plus 8n because we're building 8 miles every year and we have n number of years. So that covers our second example, and finally the last third example here. In 2014, County X had 783 miles of paved roads. Starting in 2015, the county has been building 8 miles every year at this rate. In which year will County X have at least 1,000 miles? So this covers our inequality part. I will be covering a separate lecture for linear inequalities and functions as well. But since this is all tied back to the same question, I just want to make sure I do it in this session. So again, we'll need our linear equation. We're saying that 783, in this case, let me just turn on my annotation here. So 783 plus 8n. Now it's at least 1,000 miles. When we say at least 1,000 miles, that means it's 1,000 miles or more. So it's greater than equal to 1,000 miles. a big keyword in the SATs, especially with inequalities. When it's at least, it's greater than equal to sign. When it's at most, it's less than equal to signs. So once we get this equation, again, it's all about just solving it. 810, I subtract 783 on both sides. I get 217 here. And so n has to be greater than equal to 217 divided by 8, which would just become 27 point something, right? So when we round it off, it's about 27 years. So let's just double check that. And that makes sense. So again, it's 27.125, which means that when we, let me just mark this here. So as you see, it's 27.125, and we can add it to our original amount of years. Again, we cannot have decimals in years, so technically we're saying that it is in 2042 that this would happen. So I'd like to stop the lecture here. We talked about linear equations, how they're formed, how they perform in functions, and a little bit about inequality, and we'll go more in depth with inequalities and functions next time. Thank you. Again, make sure you hit the like button. If you want me to create videos for any other specific topics, please feel free to put it in the comments, and I'll definitely create those videos. Thank you.